Hi folks, today we're going to talk about solving absolute value inequalities. We're going to build on what we did last Friday, which was solving absolute value equations. Remember that when we were solving absolute value equations, we wanted to isolate the absolute value and then we split it into two equations. One of them was the negative value equaling the right side and the other was the positive value equaling the right side. So our essential question today is how to solve an absolute value inequality. And how do we know if it's an and or an or statement? So let me go ahead and scroll down. Here we go. It says, when there is a less than or equal to sign, inequality sign, this represents an and statement. The solution is written as one inequality, so kind of like between two values, as a compound inequality. This means on a graph, the solution is shown by shading between the two numbers. So let's go ahead and try out this example and combine what we've learned from the last two sets of notes. So I do want to isolate my absolute value, and it is isolated. There's nothing over here on the left side with it. So I'm going to go ahead and split it. I have 2x minus 1 is less than or equal to 7, and I also have negative 2x minus 1 is less than or equal to 7. So something that we learned yesterday, or that we recalled yesterday from Algebra 1, was that anytime you have a negative and you divide by a negative while you're solving an inequality, that means that your inequality sign flips. So if you want to cut right to making the 7 negative, that's fine, but you need to make sure you flip that inequality sign. That's going to become important. So I'm going to go solve my inequality. I'm going to undo my minus 1 by using inverse operations. I have 2x is less than or equal to 8. And then if I divide by 2, I'm left with x is less than or equal to 4. So there's one inequality. My second inequality, I'm going to solve the same way. I'm going to undo that minus 1 using inverse operations. Negative 7 plus 1 is negative 6. And when I divide by 2, I get the x is greater than or equal to negative 3. So those are my two inequalities that I want to use. This is going to be an and inequality because I have the less than or equal to or the less than sign. So see how this is the less than or equal to sign? That means this is going to be an and inequality. So I should be able to write this as a compound inequality. So I'm going to go ahead and graph. I have a value at negative 3. I have a value at 4. If I graph the one at 4, my x value should be less than or equal to 4. So that direction. If I graph here, my x value should be greater than or equal to negative 3. So my solution is all the stuff in the middle. Remember that the and inequalities means that you are shading between the two numbers. Coincidentally, your solution should also look like your x values between the two numbers. And my inequality sign here was the less than or equal to. My inequality sign here should open to the x and it should point to the negative 3. So that is my solution. So I'm going to go ahead and scroll down to the next example. The next example is an or example. And the way that you can remember this is that when there is a greater than sign or a greater than or equal to sign, that means you use or. So or equals more. Greater than means more. So if you have the more symbol, you use the or inequality. So we're going to do the same thing with this example. We're going to split. We're going to remember the little trick that if you just go write -7 on the right side, you have to switch your inequality sign. So I'm going to go ahead and finish solving. I have 2x is greater than 8, and I have x is greater than 4. Here I have 2x is less than -6, and x is less than -3. So when I graph this, I have a -3, I have a 4. This is an or inequality because we have the more symbol. So that means that we're going to be shading in opposite directions. Even if you don't remember that you're shading in opposite directions, you can look at the inequalities and you can shade them based on their direction. So x is greater than 4 means we have an open point at x and it's shaded to the right. That's where the greater than values are. And then when x is less than -3, we have an open point at -3 and shaded to the left because that's where those less than values are. So my solution is x is less than -3 or x is greater than 4. Remember, this or is because we had the more symbol, the greater than symbol. So I'm going to scroll down to our official examples. Example 1 says solve each of the following absolute value equations. So in example 1, it doesn't say if this is an and or an or inequality, but this is the less than sign, so that tells me it's going to be an and inequality. It's not more, so it's not or. The absolute value is already isolated on the left side, so I'm going to split this into two inequalities, remembering that if I make the 8 negative over here, I need to switch the inequality sign. This is going to be something that you forget at the beginning, and you really need to practice remembering that that flip needs to happen. Okay, so don't let that that sign go unnoticed, unchanged. So I'm going to solve my inequality. I have 3x is less than 12, and if I divide by 3, I have x is less than 4. And solving this inequality, I have 3x is greater than -4, and I have that x is greater than -4/3. So I have my two inequalities. If I graph them, the negative goes on the left, the positive goes on the right. Both of them are open points. And because it's an and inequality, I shade in the middle. So there's my solution set. And if I were to write this as a compound inequality with -4/3 on the left and 4 on the right, and the x's in the middle, I would take my inequality signs from the previous two inequalities. So x is less than 4, and this relationship needs to open towards the x and point to the -4/3. There we go. So I'm going to scroll to example 2. I want you to try it on your own. That absolute value is already isolated. I can write my two inequalities. The symbol is the greater than or equal to symbol. That's more, so I'm using or. I'm solving my inequalities. I'm remembering that when I divide by a negative, when I'm solving, I have to switch the inequality symbol. I'm graphing my two numbers on a number line with the negative on the left and the positive value on the right. Because this is an OR set of inequalities, I'm going to shade outside. My points are closed. This point is also closed. And I have my solution set, where x is less than or equal to -4, or x is greater than or equal to 10. I'm going to let you try example 3 on your own, but I will give you the answer to it so that you can check your work. Pause the video and try example 3. Remember that you have to have the absolute value isolated on the left side before you can split into two inequalities. So we have to add 8. We also have to divide by 2. The symbol is the less than or equal to symbol, so we're using AND. Pause the video and continue. Go ahead and check your answer with my answer. The x values should lie between -10 and 12, and both -10 and 12 should have closed points. Let's move on to example 4. Example 4, the absolute value is not isolated, so I'm going to subtract 6. I have the absolute value of 2x plus 6 is greater than 44. This greater than means more, so this is an OR inequality shaded outside. I have 2x plus 6 is greater than 44, or 2x plus 6 is less than -44. Sorry. If I subtract 6 from both sides, I have 2x is greater than 38. And if I divide by 2, x is greater than 19. Here, if I subtract 6 from both sides, 2x is less than -50. And if I divide by 2, x is less than -25. Since it is an OR inequality, I'm going to go ahead and write up here that x is less than -25, or x is greater than 19. That's my solution. And when I graph, I have open points shaded outside. 19, open point, shaded outside. Example 5, pause the video and try it on your own. When you're finished, check back for the answer. Check your answer with number 5. And then finally, our last problems ask us to write an absolute value inequality for... Sorry, my mic wasn't up by my face. Check your answers for number 5. The last two ask us to write an absolute value inequality for each graph. Example 6 has an endpoint at -5 and an endpoint at 5. It also has closed points. So that tells me that the inequality should look like this. It's shaded inside, that means AND. That means compound inequality. Here are my two boundaries, and the OR equal to because the points are closed. So now the trick to writing an absolute value inequality for each graph is to just consider this portion right here and put absolute value around the x. Now, even though we only have 2 examples on these sets of notes about this, it's still a very important topic. It will be on exams, and it's something that doesn't take a whole lot of thought, but if you don't think about it at all, it's easy to forget. So let's try this next one. We have kind of halfway tick marks between counting by 5, so that means that this must be negative 2.5 and negative 7.5. That means that my x values are less than negative 7.5, and my x values are greater than positive 7.5. So all I want to do is consider the positive one and put absolute value around my x. So the absolute value of x is greater than 7.5.